Alright, so we're going to see if this thing can actually record me coding. I found an online Java compiler, onlineide.com. And the first thing I did was actually put my curly brace down here, just because that would bother me. Let's see if we can write like a simple prime number generating program. So, if you're unfamiliar with Java, we have a main class. That's where everything needs to be. We have a main function or a main method which takes command line arguments if we would want it to. But if you want to grab user input, otherwise, we should probably use a scanner. So the first thing I'm going to do here is I'm actually going to import java.util.scanner. That way I can grab user input that's generated from the keyboard, and then I can use that in some other ways. So let's actually change this from happy coding or hello world or whatever to we'll say something like, I know all the prime numbers. Give me a maximum number. Let me actually change that print line to just a regular old print. And then what I'll go ahead and do is I'll set up a scanner object. So I'm going to call it S. Scanner S gets new scanner. Feed it in system.in. And then what I'll do is I'll create an integer. Let's just call it num. And I'll say int num gets s.nextInt. And that's just a way of storing that value into a variable called num. So from here, let me go down here. Let me make a function that I can use to determine whether or not a number is prime. We'll call it public static. It'll return a Boolean value, like as in yes, true or false, yes or no, is it prime? And I'll call the method or call the function is prime. It will take a, let me not use num again, let's just say n. Not to confuse anybody, but that'll take an integer parameter called n. And let's work on that for a second. So what should happen is we're looking to see if the number's prime. We know the numbers are divisible by 1 in themselves, and we want to set up a loop to determine values that we can actually test whether or not they're divisible, whether or not our number n is divisible by those numbers. So let me set up a for loop. And I'm going to get my loop control variable. I'm going to start, I don't have to start with 0 or 1, I can start with 2, since we don't need to test divisibility by 1. Everything is divisible by 1. That would really ruin our program here if we started testing things if they were divisible by 1, because it's always going to be true. We'll loop up till and including the square root of the number n. And that's all we really need to do. If it's a perfect square, then it'll actually loop all the way up to its square root for like the left-hand side of our factors. And the right-hand side, again, it wouldn't matter. For example, if you have a number like 20, say that you tested if 20 was divisible by 4, and it said, yeah, it is divisible by 4 because it's divisible by, it's 4 times 5. So then you don't have to go on and check 5 times 4. Because of the commutative property of division, of multiplication, you really only need to test the left-hand factors. So that's why we're only looping up until the square root. We're going to go ahead and go one number by. We'll do k++ to indicate that we're doing one number at a time. And then what we're going to do is we're going to test every one of these values for k against our initial integer input of n. And we'll see if it's divisible. So the best way to do that is by using the mod function. So if n mod k is equal to 0, that means that n is divisible by k. We'll go ahead and break out of the entire function and we'll return false. Now, we don't want to attach an else statement to this because we're not actually tying an else into that particular, if it's divisible we're just going to break completely out of the loop. We're going to break completely out of the function itself and say, hey, this is not prime. So once it's looped through the entire for loop, and it did not ever return false, we're going to kind of default it to return true, meaning it looked for possible factors, it didn't find any, so it is then prime. Speaking of that, we can get rid of these curly braces around the for statement because it just makes our code a little bit more compact. I can go ahead and add a comment up here and say this I guess I can call it a method because it's Java. This method will return true if n is prime, n being the name that we've given to our formal parameter. So in this program, we're going to start with, again, the number 2 because we know that 0 is neither prime nor composite. We know that 1 is neither prime nor composite, so we can start our search at 2. We'll go up until we reach this maximum value, num, which up here we grabbed using our scanner. I did not give my loop control variable a name. I was going to use k again, but you know what? In this case, let's call it j, because I don't want to reuse the same, even though it's in a different scope and it doesn't really matter. Let's just go ahead and not use k twice. So j starts at 2, j will be less than or equal to num to continue the loop, and then we will increment j one value at a time. We'll go ahead and say if is prime of num, right? So if our number is prime, we'll go ahead and print it. System.print. Let me start with like the empty string to show concatenation and say j. J, and then we'll concatenate space or a comma and then a space. That seems pretty fitting. We don't need an else case here either because we're only going to print numbers if they're prime. We're not going to print them at all if they're not, if they are composites, that is. And let's give a little warning here about what's coming up. System.out.println, just print to the user and say here is every prime number below what the user previously input, and we called that num. And that looks like it'll work. Let's go ahead and run it and see if we get our favorable results. Down here is the output window, so it's going to say I know all the primes, give me a maximum number. Let's say 100. Here's every prime below 100. Did not work. Okay, let's go back to the main method. We set in all the prime numbers, value. Here's every prime number below. Let me add a space there just because it looks weird here. And it didn't print anything. Great. J starts at 2. J is less than or equal to num. J plus plus if is prime of num. I'm sorry. It should say if is prime of j. That's dumb. Okay. Let me run it again. Know all the prime numbers. 100. Here's every prime below 100. Again, formatting is weird, but 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and all the way to 97. Looks like our program is running pretty well. Let's add some extra formatting things here, a space, and maybe a double colon, because I like those for whatever reason. And let's run it again so it looks pretty. Let's get a little bit of a larger value here too. Let's say what about 360. There's every prime below 360, 2357. Once again, I'm going to add one more extra little space in there, just so it's not crowded. And there we go. If I look at our output window, we got all the prime numbers listed that are less than or equal to 360. If I know my Java correctly, this should work up to about 2 billion. So let's try it. 2,000 million billion. And it is still generating prime numbers for us at a pretty decent rate. That might take a while though. All right. That was a little bit of coding demonstration. See you in the next video.